Rendering your scenes in Karma, but you can't figure out how this thing works, or you couldn't figure out how to get your geometry into Solaris. I wasted so much time in the past just trying to figure out ways to transfer stuff from Houdini into Blender, which I used in my early days as my main rendering engine, because Blender's free. I know there is stuff like Redshift that works inside of Houdini that I used later on, but Maxon doesn't update Houdini's Redshift as much as they do for C4D's Redshift. They have a lot cooler materials in C4D's Redshift. Another advantage is Karma's compatible with the old Mantra materials. If you just want to render something quickly, for example, a pyro sample scene, you can just grab one of the pyro template materials that sidefx already has set up. But it definitely is the quickest. That means a lot for me because I'm always in a time crunch and you can always tweak the material later on until it fits your scene. It beats building it from scratch. I find a lot of Houdini users like to use solutions within Houdini itself to keep the whole workflow within one application. It reduces the learning curve time for a new application and reduces the cost, like paying for another rendering engine when Karma is already part of Houdini and available to you. Some of my audience may already know that I use Redshift, but as of recently, I stopped my subscription just because I wanted to reduce my budget. It's been a rough year to say the least. I've always wanted to dig into Karma, but Solaris was the only thing holding me back. Once I understood the basics of Solaris, I can understand why large studios would prefer USD in their pipeline, which is what Solaris is all about. Karma and Solaris go hand in hand together. You can't render things in Karma without setting up your scene in Solaris. What is Solaris? Solaris is more of a layout system, but it is essential to USD, Universal Scene Description, and it's the standard when it comes to collaboration in big VFX studios where you have to work with a load of different departments, where you need to pass the geometry files and meshes straight from the 3D artist's desk and straight into the director's hands. We get all that good non-destructive workflows that I love in Houdini, and we get it in USD. That's not all. USD also has cross-compatibility between different 3D applications, which means we're not locked into Houdini if we choose to use another application. The good old days of passing monstrous-sized Olympic files are over. Well, I don't know how USD works with simulation, so maybe not quite there yet. I'm going to use this Christmas tree as an example, and we're going to bring this into Solaris, and we're going to render it out with Karma materials. Now we need to create a LOP network in order to get into Solaris. So Houdini is all about network. So there's like LOPNET, SOPNet, and CHOPNet. So it's always like a network or network context. So that's like a Houdini thing. So let's create a LOPNet. So this will be our gateway into Solaris. Now there's several ways to create this LOPNet. One, we can create it in here. We're in the object level or in the SOP context. Now if we go up a level and this brings us to the object level, the highest level on the SOP network, we can create a LOPNet here. And it's just a place for where the LOP network sits. I personally like to put it inside the Christmas tree with like inside the object level. So it's because we're rendering this Christmas tree. So I got into the habit of putting things in one place. You can even put a fancy block here just to note that we're rendering this in Solaris and that this Christmas tree is going to be set up there. So let's enter the LOP network. This brings us into Solaris. The layout changes a bit and our Christmas tree disappears. One thing is you can come up here and what we can do is change it to Solaris right over here. This will change the layout of our panels into something more appropriate that we can actually use. This layout will be more suitable to working in Solaris. You can customize this yourself. I have my own custom one that I call my desktop Solaris, that I prefer having this particular layout. The only change is that on the right side over here, so on this side over here, you can see that there's only a single panel here. That's how I usually prefer to work because I don't have much real estate on my monitor. So let me just drop down a SOP import node. And I prefer to have the parameters on the side like this. That way it doesn't take up the entire half or quarter of the monitor screen. So that's just my preference. We can now import our the Christmas tree. So let's come here and the name was this, Out Christmas Tree. shows up in our viewport. I'm going to get rid of this stuff so we don't need that. Now over here in the scene graph, I'm going to expand this. And you can see that we have the branch, the leaves, the LEDs, and wires. So that's not too bad. Everything's here. Not quite. That only imports nicely into its respective pieces because I had set up the name attribute. Now let's go back up and I'll show you what I mean. Over here, now this is the Christmas tree. Now you can see that we have these 4 parts. These are actually just 4 wrangles of each respective part of the Christmas tree. And it's creating a string attribute into the primitives. Now we don't see it here because I'm in my specific Solaris layout. So I'm going to have to pull the geometry back out. Inspectors, geometry spreadsheet, and I want to show you what I mean. Now we're in the geometry spreadsheet and I have the primitives over here. This is called leaves. So that's what I'm sticking into in the wrangle. We're importing this guy into LOPS. So let's go back in. And you can see that branch, leaves, LEDs, wires. Those are the respective components coming from the string name attributes. If I go back and I just ignore these names so they don't exist and then go back to Solaris, let's see what happens. All the components are now combined into a mesh, into one object level. Solaris doesn't understand that they're different components anymore because we've taken out the name attribute. We actually have to tell Solaris. So Solaris depends on this graph or depends on this table. It's a good practice to stay organized. Now let me go back and put those name wrangles back in. So we have our fancy components. I don't like how this guy over here says it's SOP import 1. I want it to have something more meaningful like the Christmas tree. Let's come over to the import path prefix. This is where we can define the level of the path that it looks like in the table. So I'm going to go slash. So we start with a slash and then Christmas. Now you can see down here, it's automatically Christmas tree. And if we expand it, we still have our components. I wanted this to be in even a deeper level. We can actually do that. Come back to the path and I'm going to go slash. And if you look into the scene graph, and now we have a Christmas tree, we have parts. And if we expand the parts, we still have our different components because it's still pulling in all those name attributes. But I don't really want parts. So Christmas tree was fine for me. So that was only for demonstration. There are a number of primitive attributes in Houdini that Solaris actually recognizes right off the bat. You'll find that Solaris will recognize and then rename it for you because it's trying to convert everything into the USD format. You can find a list of primitive attributes that Solaris recognizes on sidefx's website. Now let's just go back to that SOP import for just a second. And I want to show you what this little option is all about, load as reference. Enabling the load as reference does a straight dump of our stuff, which is what we're used to, very similar to the object merge node in the SOP context. But when this option is not enabled, things get a little fancy. This option allows Solaris to import geometry in different ways and combine the different geometries in different ways as well. Because my scene is so simple, it doesn't really demonstrate this properly. The way I think of it is when this option is disabled, Solaris will do something fancy to combine the sublayers. Now the sublayers are the components that we just made using those name attributes. This was meant for large collaborations dealing with thousands of meshes and thousands of geometries in scene files in large production studios. Here I have a single Christmas tree. It doesn't really illustrate the point of this. Since most of you that are watching probably just want your geometry imported into Solaris without all the fanciness, I'm going to keep things simple and we're going to keep this option enabled. I'm not going to get into sublayering versus references, which is what this option is all about. Just remember, enabling this option, we're doing a straight dump of our geometry into Solaris. Now, notice when this load as reference is enabled, we lose that top level path that we assigned in the import path prefix parameter, that Christmas tree label. We lose that. From what I can tell, because this option has fancy ways of combining the sublayering, the top level path becomes important, but not important when we have it disabled. When it's disabled, it's literally dumping the sublayering into Solaris, but it's not a big deal. We just need to move the value to this other parameter. I'm not sure why they made it two different parameters, but we get our Christmas tree label back into the top level path. Now the next thing I want to start off is we finally get into setting up our materials. So let's drop down a material library. Now just double click it to get into it. So this is sort of like the material palette, sort of, or the material VOP. And this is where we can we're going to create a Karma material builder. And I'm going to be using MaterialX material nodes. MaterialX is cross-compatible with other 3D applications, which means if you import this USD file into Blender or another application that supports MaterialX, the geometry and materials should transfer over. Now, having said that, Karma does have its own special Karma nodes that are specific only to Houdini, and at the same time, still compatible with MaterialX. But this is a Houdini thing. Once you start using the Karma nodes, the USD file is not compatible with any other 3D application because Karma is Houdini's thing. If you stick to the MaterialX, if you stick to all these nodes, you should be fine. But note that I just created a Karma material. So you would want to create a MaterialX material builder, USD material builder over here, MaterialX builder. I'm going to start by creating a material that will make the LEDs of this Christmas tree emit light. A random color is assigned to every single LED. We need to import that color into this material. Solaris renames certain primitive attributes from the SOP level, from our object level. And it takes the ones that it recognizes, it'll rename and make it USD compatible. It'll force it to be the USD format. One of them is the CD, is the color attribute. So this is the list of attributes that our Solaris recognizes. This is the one that will be renamed we need to use. Primvars. If you just want to check out all the primvars that got imported into Solaris, we can go back to the LOPS, select our import node. Come back to this tree. Okay, we have the LED is I'm looking for, and I'm going to open up scene details because I accidentally closed it. Now these are the list of attributes associated to this LED component because this is what I have selected. Most of the attributes that get renamed that Solaris recognizes will start with primvars, will be prefixed with that. So if we come to this little search bar here, it's like a filter, this little funnel. Click that. I know it doesn't have a cursor, but it's selected. So you type in primvar. It'll filter out all the primvars for you. And here you can take a look to see what you have and what you don't have. So you have display color. That's what we're going to use. Now you also have stuff that you may recognize that you made in the SOP level. For example, I created this Christmas tree, so I know that I have a dist, which stands for distance attribute that I created, and an emission strength that we're going to use a little later to control the brightness of each LED. And there's an LED underscore number. So these are attributes that I created and got pulled in as well. Now let's go back into the material library, into our Karma material. Let's rename this. It's going to be LED material. Let's go in. We need to pull in that display color. We'll need primvar reader. Now this is going to be a color. You can actually put a 3 float. I think that'll work too. And then we're going to have display colors. Your capitals matter, so it's case sensitive. And we're going to hook this up into the base color. Oh, we have to assign this material to the LEDs. So let's go back to LOPS. You can see materials. So I'm going to expand this and we're going to see our LED material right here. So I'm going to click and drag this to the LEDs right over here in the not the outliner, the scene graph tree, which is sort of like the outliner version of other applications. And it is assigned. So it creates this assigned material node. And you can see over here that it's made the assignment for us. So you can see the LEDs now have this material or a link to this material. So let's have a look. How do I turn on Karma? That's another thing. How do I turn on Karma? Press this little drop down. I'm going to choose CPU or XPU. Click it and see if it works, it works. If it doesn't, then switch over to CPU. Now we're going to turn on the emission. So let's just go back into the material and expand this emission. And we're going to stick our color in. So this is our display. Now I'm going to click and drag it to emission color. And I'm going to turn up the emission as a test. Let's go 10. Okay, so it does look like it's still working. Okay, let's turn this, let's disconnect the base color. I want to test this. It might just be too bright, so I'm just gonna turn it out 5. White, just because it's too bright. Let me go 2. Okay, but you can see that they do have different colors. So this is bluish, this is yellowish. It's just not showing very well, just because we haven't turned this emissive material into a light source. So what I mean by that is, I'll show you in just a second. Before I turn our LED's emission material into an actual light source material, like something that will actually bounce off of it. So this right now is just, this emissive material is just making it brighter, but it's not getting that nice soft light bounces. So it's not a real light source. And also we don't have anything in the scene for it to bounce off of. So let's go back up here, and I created a really simple background, merge the background with the Christmas tree. So let me come here and let's, okay, you know what? I'll just use this thing. Background, oh, background. Okay. Load as reference. I'm going to overwrite the path name. So I have a nice, neat little table. So /background. So let's look at our scene graph. So the scene graph down here, let's move this over. There's our background. Cool. And all I really loaded is this backdrop. So let's see what it looks like after the merge. So let's select the merge and let's look at the scene graph. So it's nice and neat that we have the Christmas tree here, the background here. If we expand the Christmas tree, we still have our components. Let's go back into the material library and create a karma material. I'm going to call this background. Go in, and we don't need to pull anything in. It doesn't have any attributes. Nothing important anyways. Let's go to our MaterialX standard surface material, which acts like a principal shader. So I'm going to make this bluish, or maybe let's go back up to the LOPS, and now we're going to assign it. Oh, I forgot to get rid of that. Okay. Let's take this background, and I'm going to click and drag it to the backdrop. You'll see it updated in the viewport. Now let's go back. Let me make this bigger now. Okay, it's still not a light source, so our LEDs are just still looking bright. You can see that there's no bouncing, and also there's no dome light. There's no environment light. So first, let's drop down a karma physical sky. So this is sort of like the dome light, and all of a sudden it looks a lot better. Just because it gives us a realistic environment lighting. Well, it's an outdoor lighting though. But if you look closely, if you look into the LED, it's not emitting light. It's not really a light source. So how do we actually tell Solaris or tell Karma that we want this to be a light source? We want real light bouncing off of the emission from the LED materials. Node that we want is the render geometry settings node. Drop this down. We need to pick the geometry to apply these geometry settings to. Expand this again. Now what we want to do is take this LED over here and just click and drag it all the way up here over to the primitives. Drop it in and it'll automatically set whatever settings we put into this panel, and it'll apply it only to the LEDs. So what do we want? We want to make these LEDs into a real light source. If we come all the way down here, now what we want is treat as light, and it says no. Well, I want that to be yes. So let's click this little circle here, set or create, and I'm going to change this to yes. Okay, that's not that much better. If we look into the viewer, it's not that much better. That's because we have to turn up the diffuse and the lighting, and we might even have to turn up the emission level too. So let's come over here and overwrite this as well. Light source diffusion and light source spectacle. I'm going to turn up the diffusion. Okay, sometimes Karma gets stuck. I might just be thinking. Sometimes it helps if you turn off Karma. But it is very fast. Okay, there it goes. Now you'll really see it. Okay, I'm just gonna get a nice angle. So now you're starting to see a light bounce, and you can see that it's taking longer to render as well, just because we have so many little light sources. This is going to take even longer once we turn up the emission. let me go back to our object level. This Christmas tree, some of you may have remembered it from my previous video where on SimpleVex, I turned this Christmas tree into flashing LEDs. I had to turn off the flashing LEDs because all that was doing was making it brighter in the viewport. But we are moving on to Karma, so I needed the CD values, the color values, to be normal values. In Houdini's viewport, if you multiply the CD, which is the color attribute value, above 1, it gets brighter in the viewport. However, that will mess up Karma a bit, so I had to turn that off. And what I did was stick the strength of the brightness into a strength variable. So now, and then I had to promote it to primitives as well, because Karma is all about primitive attributes. It will only read the primitives. If you stick it into the points, it might not transfer over to Solaris, may not grab it. So this is living in the primitives. Let me show you in the geometry spreadsheet. Primitives, and we have a strength value here. You can see that some of the LEDs are the same value, some of them are different, so they're randomly flashing. Let's go back to Solaris, and we're going to use that strength variable, and we're going to feed it into our emissive material. Let's select the SOP node. In fact, put the render node here. Let's turn off Karma for a second. Select the LEDs over here, and I'm going to search primvars, and I want to find that strength. Okay, it's right. Oh, emissive strength. Strength is right here. So that's a good way to double check if it's pulling in, if you're getting the right attributes in. Let's go back into the material library. Okay, let's put the render flag down here first so we can actually see what's going on when we update the material. Go into material library, the LED material, and var reader. Drop this down, emission. And I'm going to hook it up here. And this var reader, it will be strength. It will be a float value. I'm going to call this strength. I'm here, turn on XPU. Okay, it seems a little strong. So I'm going to go back to the material, and we're going to sort of apply a fit range so we can get the emission a little lower because it's really, really strong right now. So we're going to take the strength, go MaterialX range. So this is sort of like a fit range. Apply it, and it's coming at, I believe, the largest value we're getting. If I click this over here, what you get is you can view the values of it. Let's go back. So I picked strength. So I have this selected. So these two buttons. So if you don't want to see it, or you do want to see the values of whatever you select in this details view. Oh, I think I lost it. Strength. Here it is. Okay. What I wanted to check out is what is the highest value that we'll ever get. It seems like 20 is it. I saw 20, right? Okay. There you go, 20. Okay, let's go back to the materials. So the lowest value we know is 0. And we can hit anything up to 20. What do we want to remap this to? So 0, I want some of them to be off. When they off, no emission. So 0 is correct. And the high, let's try 5. This will take some trial and error. Okay, let's see what it looks like in the viewport. Maybe 10. Or, okay, let's go 8. Let's go 8. Okay, let me pick the background so we can get the highlight off. Okay, there we go. Just wanted to get the highlight out. No, I still want more bouncing. So let's go back to LOPS. I'm going to go to the render geometry settings. And I'm going to play around with these because I want a bit more of that soft light. Let's turn this up. Okay, let me turn down the dome light just so we can have more contrast. I want the Christmas tree and the LED lights to stand out. So that's why I'm turning down the environment light. Oh, I like the nice reflections on the backdrop. That looks really nice. Okay, I think this looks really nice. Now, to set up a camera, so I don't want to keep like messing this up. So I want to set up a camera. All you have to do is type in a camera. And it acts like just like any other camera that we're used to. You come over here like this, and I want to choose our camera. There's only one, so click the little lock button, and then we can control it just like how we do, like how we always do. I'm gonna change this into, I want a 1-1 square, so I get a bit of the bottom, just because I really like that reflection. Now let's actually drop down some Karma render settings. Karma render settings. So this will control what's the resolution, how much samples you want to use. You want caustics, how much indirect lighting do you want? You can even switch. This guy is complicated. I'm not going to get too deep into this. So the purpose of this was just to get you started as fast as possible. So the minimum as much as possible. So one thing you need to know that you can turn on XPU here. So it is a lot faster. Path trace samples, you can think of this parameter as like your quality. The higher, the more expensive, the longer it'll take, but the higher the quality. So I'm just going to leave it as default as 128. Now, how do I actually render this out? This was a question that I was stuck on for quite some time. You can use the labs render node, which comes with a nice handy save to disk button. Or if you don't have the labs installed, USD render ROP, this guy. Drop that down. Then you can save it to disk. Now, the only reason why I don't have the labs installed on this guy is because I bought Houdini through Steam. It's a bit of a hassle to install it because you have to install it manually. Meaning to do it, I did it for Houdini 19, but when Houdini 20 came out, I lost all that. Just because Steam just updates it for you. You don't get a choice. I mean, you get to choose production or build version, and it automatically updates your application for you. You have minimum control. So for all of you that have been wondering, should I buy it through the sidefx website or through Steam, I would suggest to buy it through the sidefx website, because then you have more control over the application. But Steam does allow you to install Houdini on multiple machines, but you just can't use it at the same time. So you do need an internet connection to actually turn it on. Otherwise, you won't be able to use it. So there is a downside and a good side. I don't know. I've always used it on this one computer. I don't know why I bought it on Steam. There's one more thing I needed to cover. There is a denoiser in Karma. Once you go into the Karma render settings, image outputs filter. Okay, let's see. Thanks for watching and sticking to the end.